Yes, sir.
Okay, so we will start with the current topic, right? Okay, one moment. Right, I assume that you can see my screen right now because I already start with the whiteboard. Okay, so let's start. What we should be. Where is my whiteboard? Hold on. Okay, so let me know if your friend wants to come inside and I'm not currently available. Uh, Checking your what do you call the Google Chrome, the web application for Meet, in case that it will not, they will not be automatically added into the meeting, the conference. Okay, so what we are going to cover for today is what has been covered before by Prof. Eri, which is PERT, stands for the what do you call? If I'm mistaken, it's program. Okay, program evaluation and review technique. Review technique. Right. So what is actually PERT? PRT PERT. Technically, it's the same tool, uh, like the one you learned previously. Before this, you have learned about critical path method, finding the critical path. Okay, the critical path method, and this is actually a quite similar concept to CPM, right? In the critical path method, you learn about what do you call project network diagram. Okay, for example, if you have an activity A, okay, which start from first node to the second node. Okay, activity A. You do remember that for each activity there will be a duration. We call it the activity time. Okay, activity time, activity time, or activity duration. It's okay, any of this. Okay, but we are talking about the time completion of each activity. So for example, if you have an activity, we call it activity A, start from node 1 and then finish at node 2, and then we say that the duration is 12 units, okay, 12 time units. It could be week, could be month, could be days, hours, it depends on the situation. Now this is what we call as the activity time, or the duration of the activity. Now, where does the PERT comes in within the concept of the time estimate for each activity? So technically, when we start a project and then you set up the duration of the project, like for example, A is uh, probably machining task. Okay, those who are actually what do you call in manufacturing probably knows about the machining. Okay, like when you are doing your FYP or IDP, then you have to perform machining as one of your tasks. Okay, and then you set your duration, something like that. Or probably those who are actually in biotechnology, they have fermentation. For example, your FYP comprised of a fermentation process. Okay, so whatever it is, okay, you will set the activity, okay, together with the duration. uh, where do where did you get, or where do you get this number? How did you get the 12? Well, it could be from your estimation, could be from the previous data, but actually in the practice of project management, okay, to set up the activity time, okay, exactly at certain number, like for example this 12 time unit, okay, is actually quite rare because it is very impractical, because for most of the time, okay, uh, the calculation, the prediction of the activity time will not be accurate like this. Okay, now because it is quite hard to predict the activity time and the duration, there comes the concept for the program evaluation and review technique. In PERT, okay, this is the tool to actually control the project, okay, focusing by focusing to the activity time. Okay, so in PERT, okay, instead of having only one activity time like this, okay, this is one activity time, you are saying that activity A has a duration, has an activity time of 12 times unit, 12 time unit, or let's just say 12 weeks, okay, for example 12 weeks. But in PERT, you will not immediately put this one as 12, okay? But you split the approach of the activity time, okay, into three. The first one, okay, is the pessimistic time. Okay, this is the pessimistic time, okay, or I'll put the notation as TP. I think that will be fine. Okay, and then the second one will be optimistic time. Okay, optimistic activity time. Okay, this one I will put it as TO, and then the very last one is the most likely. So usually every single company or every single organization that has been performing multiple amount of project, usually they will have the data, okay, based on their experience about the pessimistic time, optimistic time, and most likely time. I'll put this one as T. Let's just put this one as TM. Okay, and the most likely time. What is the pessimistic time? So technically the pessimistic time is the predicted duration of your activity. uh, Bear it in your mind, we are still talking about activity, we are not talking about the whole project yet. Okay, we are not talking about the network diagram and whole things, whole set of activities, we are talking about a single activity first. So when we are talking about a task, an activity, okay, the pessimistic time means that uh, the time uh, we predict, okay, for the completion of the activity, where probably the activity will face a problem. So it might be, for example, a little bit late from the usual time, from the common time of the completion of the project. So we call it the pessimistic time. Like for example, okay, activity A, biotechnology student will say that I'm going to finish the fermentation within 12 weeks. Well, in theory, usually based on the schedule, like, oh, okay, this is first week, second week, and so on, and then I believe 12 weeks will be ready. But just in case if something happened, like for example, the shaker is broken or something else, so you say that the pessimistic time must be usually bigger, okay, or longer in terms of length of time, okay, compared to the normal one. So we call that the pessimistic time is probably a little bit late than the common time. The optimistic time is at the opposite. The optimistic time. We assume that every single task, when we are trying to complete the task itself, everything will be smooth. Everything will work accordingly, and as a matter of fact, we probably could finish faster for the optimistic time. So optimistic time is usually the time where the task itself can be finished, okay, more than the theoretical or the common time. And the most likely time is usually the
Sorry,
time.
sir.
Yeah. Okay.
Someone waiting to join the class.
Oh, okay. Okay, hold on. Right. Okay, so let's wait until everyone is joining in first. Still beeping. All right, I hope we can resume again. Okay, so back to the whiteboard. Where are we? Okay, the most likely time. Again, for those who just joined, okay, the PERT will divide the duration, the activity time, okay, not into a single time of completion of duration, but instead we will approach it according to the three uh, completion of time. The first one is the pessimistic time, assuming that our activity, not the project itself, our activity, that specific activity will have uh, a problem, okay, and then it might be just a little bit late or probably literally late, okay, maximum late, the one that can be predicted. And then the optimistic time where everything should be smooth and then probably we can even finish faster. And the most likely time where most of the time, okay, it can be from the experience of the organization of the company, probably multiple times handling the activity and say that okay, most likely it will be finished by this time, the common time. Okay, we call that one most likely time. So all the calculation later on will be conducted according to this three. Okay, so let's just jump into the calculation, right? Hold on. So, okay, before we jump, I need you to understand, okay, the concept of the three first. So, which means that when it comes to the measurement of time itself, that means the pessimistic time is usually, okay, sorry, not the pessimistic time. Ruler, sorry, eraser. Okay, the optimistic time usually will be shorter, okay, than the most likely time, right? And then the most likely time will usually be shorter than the pessimistic time. So we assume that the pessimistic time will be the longest one, okay, in terms of completion of time unit, and then the optimistic time will be the shortest one. Okay, so you have to remind this one because this one will be coming in the calculation later on, right? So because usually neither the optimistic and the pessimistic time that uh, what do you call neither the pessimistic time or the optimistic time that in practice can usually come up, which means that for most of the time the activity will be completed in the range of the most likely time. Okay, so later on when we want to calculate the duration, like we put it in the network diagram like this, okay, we will put a higher weight, okay, a larger weight, okay, for the most likely time compared to the pessimistic time and the optimistic time, signifying that actually we are going to calculate the most likely time, okay, having the largest opportunity to be implemented rather than the other two. Okay, for the duration later on, okay, in order for you to calculate the critical path later on, and then knowing the completion of the activity like this, okay, the 12 here, okay, you have to change later on the pessimistic time, the data for the pessimistic time, the optimistic time, and the most likely time into something we call as, let's just call it time estimate. Okay, the time estimate, okay, I'll put this one as TE, okay, so you can memorize it better. The time estimate is the calculation from the three over here, from the pessimistic time, optimistic time, and most likely time. So technically what you put into the calculation for calculating the network diagram is the time estimate. You are not using the pessimistic time, you are not using the optimistic time, and you are not using the most likely time, but instead you are using the time estimate, okay, the calculation of this three, okay, the pessimistic, optimistic, and most likely, okay, and then put it into the network diagram to calculate the early start, early finish, slack, and so on. So what kind of formula? Like I said before, That means that since most likely time is actually having a greater weight compared to the pessimistic and optimistic, okay, we have the convention for that. So technically, the time estimate will be equal to, okay, TO, right, the optimistic time, plus, okay, no, I put it in capitals, so you're not going to be confused. One moment. Okay. So the optimistic time plus, okay, the most likely time and the pessimistic time. Okay, but because we put a larger weight for the most likely time, okay, statistically, because we are using statistical method for PERT, okay, so for the calculation of the TE, we are going to put 4 for the weight of the most likely time. So TE equal to TO plus 4 TM plus TP, okay, because we have this one 1 for TO, 4 for TM, okay, and then 1 for TP divided by 6. So TE is actually TO plus 4 TM plus TP. Okay, so this is the formula for calculating the duration, where this one, the TE, will be used for the calculation of the network diagram, for the calculation of the duration in the network diagram. Okay, so memorize this one first. You can take a note on this later on. I believe it should be given in the slide as well. Okay, so next, let me see if we have a good example, okay, for the calculation, for the questions, okay. Okay, one more concept before we start. Like I said before, the time estimate, okay, now, so you will memorize it easier. Okay, note 1, note 2, activity A, and then let's just put the duration, for example, 12. Okay, so this one is technically equal to what we call as the time estimate. Okay, notation could be different from one reference to another, so don't be surprised about the notation itself, right? So TE will be equal to the optimistic plus, sorry, for most likely, and then the pessimistic divided by 6. Okay, so this is what we are going to do. Anyway, if you have any questions, because I couldn't see the chat, you have to immediately interrupt me for anything, because this is not a conventional class. You can always interrupt me anytime if you don't understand. Right. Okay, now the time taken by the activity, okay, in a project usually follow a distribution. There is a standard deviation of 1/6 of the range. Okay, so when we have the standard deviation for uh, the project, okay, standard deviation for this, that means that you do remember that actually TO is smaller than TM, okay, and then this one will be TP, right? If you memorize this one, okay, that means that the range of a project, okay, is actually the time, the pessimistic time minus the optimistic time. Okay, which means that if, let's say, for example, the optimistic time for this is actually 8, and then the pessimistic time is actually 16, okay, so the range is actually 16 minus 8. Okay, the most likely is 12, for example. The most likely will not be 12, but will be calculated using this one. Okay, so you decide what is the optimistic, pessimistic, and then you can calculate the what do you call it, the deviation later on. For example, if the most likely is 12, and then you go to the time estimate for this one. So the range is TP minus TO. So that makes the standard deviation for this we use usually the notation of sigma. Okay, bad practice, bad practice. One moment. Okay, so the standard deviation for time distribution will be, I'll put it here, standard deviation, or with sigma, standard deviation sigma, that will be equal to the pessimistic time, right? Like 16 minus 8. And the pessimistic minus the smallest one, optimistic, again. Okay, please don't mind me if I use the lowercase. Sometimes I mix it with the uppercase. It's a bad habit actually. Okay, stick to the notation. TPTO. Okay, divided by, because the total number is 6, so the standard deviation will be this one. That makes the variance, okay, as you learned before this from the statistic lesson, the variance will be sigma square, which is actually TP minus TO 6. Okay, so this are the tools that we are going to use to calculate the probability of completing a project, okay, within certain range of time, okay, and also to calculate the time estimate of the whole project. Right, so let's give you the small calculation, not small calculation, an illustration. Okay, if let's say that you have an activity, again, you have an activity, okay, this time back to our example, 1, 2, 8. Okay, now you have an activity, activity A. Okay, now if let's say that your friends, okay, for example, I call it Amir, I don't know if you have Amir or not, and after that the second person is,
Can you allow somebody waiting outside?
oh yes, yes bro. Okay, right, have everyone entered? Okay, so
Hanis and who is this? 2 person.
all right, okay, anyone else? Okay, if someone else would like to join, please let me know. Don't let Prof. Eri to give you the notice. Ah, okay, all right, okay. Only one.
Sir,
Yeah,
can you record this?
it is recorded. It is recorded.
Is it? Okay.
Yeah, my screen is recording right now, but I'm not using Google Workspace for recording, so the result might need be a little bit editing later on. Okay. Or you will see my screen sometimes. It will be, the raw one. Okay, so we go back to our illustration here. Okay, let's say that let's talk about the concept of the variance in terms of what do you call the time estimate. Okay, for example, if let's say that you have an activity A, okay, activity A, which is writing FYP report, for example. For Amir said that he will finish, of course, it will be divided into 3, optimistic, most likely, and then the pessimistic one, right? Again, and we have 2 students, Amir and Hanis, in this example, okay? For activity A, which is writing your FYP report, let's say that Amir will take around 4 weeks for the optimistic, and then for the most likely will be 6, and this one will be 8, pessimistic. And then Hannes will say that it will be 4, okay, and most likely it will be within 7, and then 10. Okay, now talking about the probability, okay, if we would like to know, okay, which one of these, which one between Amir and Hanis, okay, has a higher certainty, okay, on the time estimate, okay. So we have to calculate the variance, we have to check it according to the variance of the time estimate, okay. So what we should do for this one, okay, we have to calculate the standard deviation first, which is actually, okay, or we can jump actually into the variance, which is t, oh, that's wrong, tp, okay, minus to divided by 6. So this one, okay, for Amir it will be, okay, 8 minus 4 per 6. Okay, let's grab this value. Please let me know what is the what do you call the result of this, okay. And then Hanis, okay, this is for Amir. Please let me know what is the result, okay. And then Hanis will be having the variance of let's just jump into it, 10 minus 4 per 10, 4, 7, I think. That's correct. Okay, this one will be 8 minus 4, 4 per 6. What is this?
0.44.
0.4. Okay. And then what about Hanis? This one, 10 minus 4, 6. Right. What is this? What's the result?
0.73.
0.7.
7. Yeah.
Okay. Now, because Amir has less variance for this one, okay, if you have to choose which one, okay, has a better time estimate, which one is more certain in the time estimate, then you have to choose the one with the smaller number of variance. Okay, so you stick, okay, to Amir instead of Hanis. That's how you use the variance in this case, right? Okay, that is for if you are asked, okay, what is the function of the variance? Okay, smaller variance should be better, which means that imagine if actually you have, let's say that there's a third person, which is you, okay. Now, if let's say that actually the optimistic time is 8 and then the pessimistic time is 8, right, and then whatever the value of the most likely, okay, your you will not have a variation, okay, less variance, okay, between the TO and the TP, which means that actually you are more certain, okay, in completing the in having time estimation, because you have a lesser degree of TO and TP in this matter, okay. So imagine this one in the real implementation. Right, let's go to the next one.
Sorry, for uh, a second.
Yeah.
For Hanis, why it is divided by 7? Is it because of TM?
Repeat again. I couldn't hear you clearly.
For Hanis,
Hmm.
when we calculate the variance, we divided by 7.
Mm-hmm.
10 minus. So this 7 is actually
Hi.
different.
See. Okay, correct. Why didn't anyone remind me of this?
That one should be
I
6, right?
also mistake.
See, this is because I am a little bit, you know, that's why I need my coffee actually. Right, hold on. One moment. Okay, so which one? Okay, back to the whiteboard again. 10 minus 4. This one is 6. Okay, which means.
6.
So what is the
1.
result? Just give me the result immediately.
1.
1.
1. Okay, so which one is better still? Still, Amir is better. Okay. Right.
Sorry,
So
sir. Can you repeat why we choose the smaller variance to calculate what you say just now? To see.
okay, here's the thing. Like in the real implementation, will you rely to someone? Okay. Let's say that you are having an IDP with your friend. Okay, and your friend say that one. And the task is actually to, let's say, to purchase equipment. Okay. Then your friend say, okay, you ask your friend, okay, Amir, you ask Amir, uh, what is the fastest time, okay, can you suggest, okay, to complete the purchase, the equipment? You go out and then just purchase. He said that 4 hours. Okay, 4 hours. What about the pessimistic time? Okay, he said that 8. Well, we don't know why did he say 8? Maybe because he has another things to do. Okay, and so on. Okay, and Hani said 4 and 10. Maybe she has something else to do too. So the question is, which one between Amir and Hanis is more certain? Okay, is more certain in completing the project, in having the estimated time of the completion of the activity. Remember, you have to calculate the duration later on. Okay, if you need the number over here, the duration of the activity, what is the function of the duration of the activity again? To get you in the planning stage, to get you to the calculation of the total time estimate of the project. If let's say that Amir said that the optimistic is 4 and the pessimistic 8, resulting to variance of 0.4, and Hani said between 4 and 10, which value, okay, which value of time estimate will you take for putting the duration below the activity in the network? Did you get it? Okay, imagine one more time. You have a project. You are in the planning stage. You are having a kick-off meeting with your friend. Okay, you are creating a network diagram. Okay, you are discussing. You have activity A, which is procurement of equipment. Okay, and then nobody knows about the procurement of equipment. Okay, we want a very accurate calculation on when can we finish this project. Okay, when can we finish this project, because it is related to our writing later on, related to our graduation. We need to be precise in the estimating the total amount we need to complete the project. That's why we need a certainty, a good certainty in the duration of each activity. Then you ask Amir, what do you think about purchasing equipment? Well, fastest by 8, fastest by 4, latest by 8. And then Hani said, well, fastest by 4 and latest by 10. So which value do you want to take? Which number are you going to put here? The number comes from Amir or the number comes from Hanis? You have to take the number, the one that has better certainty, less variance, which is 0.4, which is Amir for that. Okay, that one we call it, we are having less variance for the calculation from Amir, okay, compared to Hanis. But usually this kind of calculation will not be asked, I think, later on. I mean, it's quite rare unless you are being asked for the concept in the exam later. Okay, do you understand?
Yes, sir.
Okay.
Thank you.
Right. Next, I assume that your friend doesn't have any problem in entering the session, right? Okay. So next, I will give you another small example. Okay. Let me copy the question first. Where is it? Okay. Right. Here we go. One moment. Let me copy the file. Copy the text.
Sir, I think that someone is joining, asking to join.
All right. Okay. Right. Still? Okay, let's go back to the example. Now, I give you the example on the calculation. Like I said before, again, focus to what we call as the duration of an activity. Again, okay. Oops. You have node 1, then node 2, you have activity A, and then you have time. In this case, I'll just give you an example. So we really are focusing to the topic of this one, okay, the activity duration, or activity time. Okay, now I have an example. What did I do? You still here? Oh, okay. What did I do just now? Sorry. Copy. Right. Okay. Can you see my screen still?
Yes, sir.
Right. Okay. So we have a question over here. Okay. We have a question. Okay. The question is. Sorry. Okay. The question is, find out the time required, okay, to complete the following project and the critical activities. So technically, you will be asked for the critical activities. Please, okay, and before, what is it? What are the critical activities, and then project completion time. Project completion time. So different from the assignment before, instead of having one type of duration, okay, you will have three: the TO, the TM, and this is TO, this is TM, and this is TP, the pessimistic time. So how to solve this? How can we know the project completion time and the critical activities from this kind of thing? Okay, first of all, we need to calculate first what is actually because when you are creating network diagram like this, okay, below the network, below the activity, if it is activity on arrow, or still similar with the activity on node, you will just put only one duration here. You are not going to put three type of duration, the optimistic, most likely, and then pessimistic. No, you are just putting one. So what is this actually? This is what we call as the the time estimate. Okay, the TE, right? So again, what is the TE? TE, we calculate it as optimistic, and for most likely, and pessimistic divided by 6. So you add one more column over here on the right side. Apologize for the ugly drawing here. Okay, and find
Sir,
out. Yeah,
it seems the same assignment you gave us.
say it again.
It seems the same assignment you gave us.
Are you sure?
Yes.
Double check
Yeah.
one by one.
50.
Double check one by one.
3, 8, 9, 8, 16, 16, 2, 1, yes, 6,
Mm-hmm.
4, 6, 10, 12,
Mm-hmm.
9, 21, 22, 5, 3, yes,
What about
6, 9, 12, and 15, 10, 26, 25, 8, 5, yes,
is it?
and principal A, C, D, E, D, E,
Mm-hmm.
F, G, yes,
Yeah, the same.
completely same.
Identical. Did I take
Yeah.
it from your accidentally?
So,
Okay, hold on. How many assignment did you receive? 2.
3.
from PERT,
Mm.
2, and source 1.
Hold on. Let me check first if I take it from my question banks. Well, if that's the
Just
case, let's just change the
continue.
question a bit. Well, what is the submission day for you? Did you submit it already?
For this one, 18 is coming.
Not yet.
Tomorrow.
No,
Tomorrow. Now,
17
if you
tomorrow.
are finishing it tomorrow, then you will be
17 is for
at the
resource, right?
advantage. Okay. Uh, okay. If that's the case, hold on. Let me take another one. You shouldn't have told me actually. Now I'm changing the questions.
I
Why,
was
Uh,
afraid
brother?
that
Why?
when you realize that the
uh,
same question you teach, then maybe you get the assignment. That's why I say.
okay. If you are sending something from the chat, please let me know. Read it for me because I'm right now at the other I think I have another note. Hold on.
Someone said astaga.
It's like, okay, thank you. I think I'll take this one. Hold on. Yeah. Going to take this. There we go. Copy. What did I do? I think this one. There. Renew. Okay. So for this one, oh, this one is shorter. Never mind. Okay. This one should be shorter than the one I gave to you before. Okay. So you have this time you have 1, 2, 3, 4, 5, 6 activity. Like I said before, the time estimate, okay, will be plus 4 most likely, and pessimistic divided by 6. Okay, so what you have to do, okay, is to calculate the time estimate first. So you add the time estimate over here first to find out what is, okay, the critical activities. Look, it's the same, I think. Project network diagram, calculate the time estimate and the project duration. Okay, after all, you will not be able to do anything without making the project network diagram and perform the calculation of the time estimation first. Okay, so you have to calculate what is the time estimate for all of this first. Okay, so in order for you, sadly I didn't do the calculation first. I didn't do the calculation for this one yet, so you have to assist me in finding, oh sorry, I need to silence my phone first. Okay, in finding the TE. Okay, so take out your calculator and give me immediately what is the TE for all of this activity. So what is the activity for 1, 2 activity? You notice this one, right? Okay, you should be familiar with this one. That means that this one is activity 1 to activity 2. Okay, and then after that 2 to 3, 2 to 3, like this. This is activity on arrow. 2 to 3, and then 2 to 4. Okay, this is the network diagram. We will do the network diagram later. Assist me in finishing the TE first. Give me the number of the TE, starting from 1 to. What is 1 to?
30.
Okay, hold on. Let me erase this one. We will. No, my bad habit. Paper is dirty. TE for this is 13. 2, 3.
30.
Huh? What is
13.
13 again?
No. The for 1 to 2 is 30.
1 to 2 is 13.
30.
30.
Oh, 30. Couldn't hear you clearly. Okay, spell the number. 3023
13.
13. Sorry, because I feel lazy to calculate it. 24 Come on, faster.
20.
40
20.
20 35
16. 16.
16 45
6.
6.
6.
Okay.
Yeah.
And then 5 6.
5.
5 6 is 5. Alright, so we have the TE. Now we develop the network diagram first. Right? So activity 1, definitely there's no predecessor. Go to activity 2. Activity 2, as you can see, it's split into 2, 3 and 2, 4. So there is activity 2, 3 over here. Okay, and there is something called as activity 4. Right? Then 3 will be followed to node number 5, and 4 to 5 as well. So which means that 5 might be somewhere here, like this. 3 to 5, 4 to 5. Then the very last one, okay, will be 5 to 6. Okay, let's just put this one as A, B, for example, C, D, E, and F. Right, so for A over here, 1, 2, you have 30. Okay, for 2, 3, you have 13. Okay, and then followed by 20, followed by 16. 3, 5 is 16, 4, 5 is 6, and this one is 5. So which one is the critical path? Sorry,
5.
critical activities. So the critical activities are, which one? A.
The longest one.
Yeah, of course, the longest one. Do me a favor. Which one is the longest one? A, B, D, F, or A, C, E, F?
A, B, D.
A, B, D, F.
Yeah. A, B, D, F.
A,
B.
B. I assume that you can calculate and choose which one is the critical activities from the previous tutorial, okay? A, B, D, F. You sure?
Yes, sir.
Yes.
Okay, A, B, D, F with, okay, duration, okay, of, sorry. What is the duration of the project?
64.
64.
Project duration equal to 64. 64 weeks, or what is this? Not defined. Okay, 64 time unit. There, we finished from question A. Any question for this? No, right? So, as you can see over here, this number over here, for the calculation of the critical activities, should be taken from TE. And TE should be calculated through the calculation of optimistic, most likely, pessimistic, divided by 6.
Kau tengok Netflix itu us tu.
You forgot to turn off your microphone. We can hear you, actually.
Sorry.
No, it's okay. You are cooking or something? Right, so next question. What is the probability of completing the project before a scheduled time? Okay, now for that one, okay, we already know that the critical before we go there, okay, before we go to the calculation of question B. Any question for question A first? Any question for A?
No, I think.
Okay, so it's quite
No,
easy.
sir.
Quite easy and straightforward. All right. Okay, so hold on. Let me find the. I don't have the table. Never mind. Okay. Right. Now we know already, based on answer A, that the critical activities is actually A, B, D, and F. Okay, and the project duration is 64. So how to calculate, okay, the probability of completing the project before the scheduled time of 67? Now again, okay, we already, let's label it this one first. A, B, C, D, E, F. Now pay attention that actually our critical path is actually only A, B, D, and F, correct? So only 4 of them. I think I'm going to, where should I put it? One moment. I'd rather to, I don't want to Mm. Yeah, okay. Sorry, otherwise we will not have the proper space later on. Okay, so once we know that the activity, we have 4 activities, which is A, B, D, F. Okay, we are going to make, let's just make it, let's just make a new kind of table. Okay, it will be easier, it will be neat. Okay, you have activity A, you have activity B, D, and F. Okay, you have also the calculation of the optimistic time, okay, most likely time, and so on. What you have to calculate again, okay, is the range of the time, okay, the TP minus TO. Okay, for the TP minus TO, the range of activity from A is actually 47 minus 17, right, which is actually 30. The TP minus TO, the range of activity B, is equal to 18, correct? Correct me if I'm wrong, because I feel a little bit sleepy. And for D, 19 minus 13, which will be 6, okay? And then for the last one, 8 minus 2, which will be 6 as well. Now we have the range, so definitely we can calculate the standard deviation. Oh, sorry. 8, 2, 6. Okay, so we have to, we can calculate the standard deviation for this. Standard deviation for this, what is the standard deviation for this one? 30 divided by 6. This one will be 5, correct? You forgot.
Yes. Yes.
Standard deviation is TP minus TO per 6, correct? Where is the thing I put?
Overlap.
There. Okay, so this one will be 5, this one will be 18 divided by, this one will be 3, this one will be 1, and this one will be 1, correct? Okay, and then the variance for this one is, this one will be 25, 9, 1, and 1. Okay, okay, now since you got the data for this one already, okay, what you have to do, okay, is to calculate the sum of variance first. Okay, so the standard deviation, hold on, we need the table later on. Okay, we're here. Okay, so based from this calculation, the variance, okay, of the project time is equal to sum of variance, which will be equal to 25 plus 9 plus 1 plus 1. This one will be 25, 29, 34, 36. Am I correct? 36 time unit. Can you confirm with this? Okay. The sum variance for this one is 36.
Yes.
Correct?
Yeah,
Right.
correct.
So the standard deviation of the project time. Take a look at this. I'm talking about project time. I'm not talking about activity time anymore. This is the variance for activity time. This is the standard deviation of activity time. 5, 25. This is for activity. I'm talking about the project time. Okay. For the project time, the sum of variance, the variance of the project time is actually the 25 plus 9 plus 1 plus 1. Okay. And for the standard deviation of the project will be calculated, which is the square root of 36. right? Because the total of the sum of variance is 36. Okay, so this one will be 6 time unit. Okay, right. So after that, oh, I forgot to give you one more formula. Okay, now we already know that the sum of variance, the variance of the project time is actually 36 time unit, and then the standard deviation is actually 6 time unit. Okay, back to the question. The question is that what is the probability of completing the project before the scheduled time of 67? Okay, the probability of completing before 67 weeks. Okay, as you can see before this, okay, based on our network diagram here, based on the critical activities, the calculation, okay, from the critical activities, we will be finishing the project by 64 time unit. Okay, the weeks or time unit. Okay, not weeks, time unit, regardless of the unit of the time. Okay, so but this is not definite. 64 is not definite. That's because we calculated, okay, based on the time estimate. So the question is, if let's say that I say that the project will be completed by 67 week, okay, 67 time unit, what are the chances that it will be completed based on the amount of time I said here? Okay, in order for you to calculate that one, okay, you need another calculation for the standard normal variate, okay, which is you have to calculate the value of the z. Okay, for this one, this one's supposed to be the given value of the time, which is 67, okay, minus, okay, the expected value of time. This is from the critical path, okay, divided by, okay, standard deviation for critical path. Now you have to pay attention, okay, and don't make mistake. This is from the what we calculate before from the critical path. For critical path. So the z value for this, okay, is actually 67 minus, what is the value for the project duration? 64. Okay, 67 minus 64, okay, divided by, hold on, standard deviation of 6. Right, what is the value for this? Can you calculate it for me?
1/2.
0.5.
0.5.
0.5. Hold on, because I need to open the table after this. Chapter 5. Okay, let me find it. Never mind. Okay, so 64, 67, 64, you said 0.5, right? Correct? Okay.
Yep.
Plus, minus, plus 67 minus 64, because this one will define the table later on. Now you have the z value. What you have to do with z value after this, if you have, I think you can find it easily later on from the internet. Okay, what you have to do after you get the z values, this is not the probability. Remember that we are asked for the probability of completing before 67 weeks. Okay. Now we have the z-value of 0.5, which is not the probability yet. What you have to do after that is to actually to refer to the normal probability distribution table. You can find it from the internet later on, I think. And then check the value of 0.5. Okay, that is corresponding to z equal to 0.5, and then you will find what is the value for this one. For example, okay, if later on from the normal probability distribution table, okay, the corresponding one you get 0.5, I think somewhere here, 0.69. Okay, then the probability of completing, for example, if it is 0.69, okay, you get the value of 0.69 from normal probability distribution table later on. Then the probability, okay, the answer is like this: the probability of completing the project before 67 weeks, 67 time unit, is 69%. That's the answer. Okay, so usually for most of the situation for this kind of questions, you will be asked to calculate in several stages. First, you have to draw the network diagram and then provide the calculation of the TE first. And then after that, you will be asked for the probability of completing the project before scheduled time of certain specific amount of time. The value could be positive, could be negative for the z, but regardless, okay, for that one, you have to refer back to what do you call the normal probability distribution table. You get the value, and this is the percentage, the probability, okay, of the completion of the project. Okay, only that for the part. Okay, any question for this? Any questions? Okay, I'm going to the chat now. You can send your question from chat. No, okay, good. If you don't have,
So, sir, for
Yeah, I have
PERT,
question.
yeah, okay.
sir,
What if we
One
type
by one,
the
one by
answer
one.
in
Mustaqim
decimal
first.
form?
Okay, okay, hold on, Mustaqim. I'll give Sajad first. Sajad, go ahead.
yes, sir. I'm asking that for PERT, when we will find the critical path, we don't need to find